In three-dimensional space, we add a third z-axis, which is perpendicular to the other two. We can express an infinite number of points with three coordinates. There is again a special point with coordinate 0, 0, 0, which is the origin. Any point 3 value can be expressed as a three-dimensional vector connecting the origin and the point in question. In 3ds Max, the world coordinate system is such a three-dimensional space with x and y axis defining the ground plane and the z axis pointing up. In MaxScript, three-dimensional points are expressed as so-called point 3 values. We can construct a new point 3 value by using the point 3 constructor and listing the three components, or in the shorthand version by using the rectangular brackets and separating the components with commas. The same rules for addition, subtraction, and scalar multiplication apply to three-dimensional vectors. We only have to deal with one more component. Similarly, we could add, subtract, and multiply vectors in hyperspace with more than 3 dimensions, but this makes sense only in mathematics and has no application in typical 3D graphics, so we will stop with 3 dimensions. For example, we could multiply a point with 2, and the result would be 20, 40, 60, and we could add a point and another point, and the result would be 110, 220, 330. The graphical representation of the three components is again just like with two-dimensional space, the projections of the point onto the three axes x, y, and z. Let's connect the origin and the x projection, the origin and the y projection, and the origin and the z projection. Again, using the same rule of addition, we could take the y vector and translate to the end of the x projection vector and then project the z vector in order to add the x, y, and z components and get the sum, which is the point 3 value we are working with. So the same rules apply to one-dimensional, two-dimensional, and three-dimensional space. That's why the logic shows us we could go on with n dimensions in theory. In practice, in 3ds Max, it's enough to work with point 3 values to solve most of the problems typical for 3D application. Let's take a look at vector subtractions. In this case, we have a point A with position 100 to 150 and another point B with position 20, 40, 60. In order to calculate the subtraction of point B from point A, we could graphically create a new vector going from point B to point A, and its length would be equal to the distance between the points A and B. The length of a vector can be calculated using the method length